Hi. Welcome. We're going to go ahead and get started while the last people tear themselves away from the buffet in the interest of everybody's time. But I want to welcome everyone and thank you for being here. For those of you who don't know me, my name is Lisa Wallach, and I'm proud to serve as president of the New England Chapter. And I also serve on the JDRF International Board of Directors, all JDRF all the time. And my involvement with JDRF started before there was a JDRF. For those of you that have heard my story before in events like this, I apologize, I'll try and add something new and different. But my brother was diagnosed in 1970 at the age of 18 months. So he is coming close to his 50-year anniversary of living with type 1 diabetes. We grew up in Connecticut, and he came to Joslin, where he received his care over many, many years. And at that time, there was no organization devoted to finding a cure or funding research for type 1 diabetes. And I'm proud to say that my parents were among the original families that banded together in a grassroots effort to form what is now JDRF, this huge organization that is doing such extraordinary work around the globe. My personal involvement, and it's not that I don't care deeply about my brother, I obviously do, but it ticked up a notch when our son was diagnosed at the age of 5 back in 2001. And after that, we had moved here to the New England area, and I started getting involved as a volunteer with the New England Chapter. And here I am today as an ongoing passionate volunteer with the New England Chapter and beyond, and incredibly proud of the progress that we have made to date. My son, Harris, who's about to graduate from college in 2 weeks now, and my brother Scott are both benefiting from the new hybrid closed-loop artificial pancreas system that Medtronic 670G, for those who have heard of it, just came out on the market within this past year, thanks in large part to efforts by JDRF to advocate at the FDA, and it goes way back, the story, to the early years of convincing some of the researchers at Yale and other companies to get involved in this space to create these products that I think most of our loved ones are now benefiting from. And I can tell you that we have a long way to go, but boy, have we come far. And if anyone has questions they want to ask me about the 670G, I'm happy to talk to you afterwards. But that's just one example of the extraordinary progress that has been made thanks to everybody's support and the efforts of JDRF. We are absolutely thrilled today to have Dr. George King here presenting on his extraordinary research. For those of you who were at the New England Gala last year, Dr. King was presented with the Nancy Jones Diabetes Champion Award, and there was a wonderful 3-minute video that was made about the work going on at his lab that we've actually brought today to show those of you who haven't seen it or those of you who want to see it again. But the feeling in the room was, that's amazing, we want to know more, and so we invited him, and he graciously agreed to come to join us this evening and give us more detail than the 3-minute synopsis was able to cover. Dr. King is also the recipient of the 2016 JDRF Mary Tyler Moore and S. Robert Levine Excellence in Clinical Research Award for Type 1 Research, which recognizes outstanding clinical and translational T1D research and is named in honor of JDRF's former chairman, the late Mary Tyler Moore, and her husband, S. Robert Levine, MD. We all miss Mary, I'm sure, and the extraordinary leadership that she brought to this organization, and the role model that she served as for so many of us, being one of the first to come out so publicly as someone living with type 1 diabetes. I have the privilege of introducing our first speaker, Dr. Julia Greenstein, who is the Vice President of Research Strategy at JDRF. We are incredibly blessed that Julia lives here in the Boston area. She actually works in New York at the headquarters of JDRF, but because she lives in our neighborhood, She always graces us with her presence and her expertise, and comes and helps us to understand the overall context of the research that JDRF is funding, the different priority areas of where strategically our dollars that we work so hard to raise and contribute are being spent. And Julia, who's been at JDRF, I don't even know for how long, I'm not going to say, but for a very long time, and who was in biotech before, comes with extraordinary expertise and strategic vision, and has really led the research department at JDRF to go beyond a grant allocation exercise, although that's an important part of what we do, but to really be proactive in identifying extraordinary researchers and driving the research agenda that enables us to really be on the cutting edge, but also really driving the field to do the work that we need doing to help find a cure and to make life easier and safer for everyone living with type 1 while we wait. So Julia, please do come up and share some of the overall context of what we're doing at JDRF. Thank you.
Thank you, Lisa. It's always a privilege to kick off these events. I'm going to try to spend a pretty short amount of time, because you really want to hear from Dr. King, sort of setting the stage of JDRF's overall effort in the research area, and also just a little bit about the context of what we've decided to do in the complications of diabetes space. So obviously our overall mission is a world without type 1 diabetes. We really sort of refined that recently with the mission committee of the board to really accelerating life-changing breakthroughs to cure, prevent, and treat type 1 diabetes and its complications, because we want to make sure that the daily burden of type 1 diabetes is diminished in people's lives, and we want to keep people healthy so that when the cure or cures are available, people can get the best benefit from them. And so we really work what we call across the development pipeline. JDRF very much started its early days focused on basic discovery research, which was appropriate 40 years ago, because we didn't really understand very much of anything about what type 1 diabetes really was. And we've learned a tremendous amount about the immune system and about the beta cells and how they interact with each other. And that's caused us to say, well, we need to grow the organization in a way that we really push translation to people with diabetes. So it's important to continue our basic science research, but we need to start working in translational medicine and push the exciting science that we see in the basic research labs toward the clinic. And so JDRF has been very proactive in now doing that with our academic colleagues. We have broadened our umbrella, and we start working with biotech companies and industry, because if we need those partners to bring solutions to people with type 1 diabetes. JDRF will never be able to afford what we call a phase 3 registration trial in the US. We need to have pharmaceutical companies who will jump in and start spending their resources to really develop these drugs further. And JDRF really serves as a de-risking organization to bring other people in, and very recently, some of you have heard more about this, we formed a type 1 diabetes fund, JDRF Type 1 Diabetes Fund, that now allows us to invest equity in young companies and really push people to develop companies that are centered in projects to develop solutions in type 1 diabetes. The other thing we do is advocate. Many of you are advocates for JDRF. Special diabetes funding makes a big difference in what the NIH can do for type 1 diabetes research. And we make sure that the regulatory path is clear. So companies won't go in unless they know what they need to do to develop a drug in type 1 diabetes. And so JDRF is very proactive with, mostly right now with the US FDA, but we do work internationally, and we spend a lot of time with the FDA, making sure they understand type 1 diabetes, making sure they understand the science that's coming down the pike, and making sure that the guidelines really make sense from the perspective of type 1 diabetes. So all of that wraps into what we do, but we remain centered in curing type 1 diabetes. We've added a big prevention portfolio, and obviously we want to treat and make glucose control better. In order to do that, I mean, I sometimes feel like my first job is not to spend JDRF money. We spend a lot of time talking to pharmaceutical companies and working with our foundations who work with us closely, like the Helmsley Charitable Trust. And if I can convince them what I think is important to do, what we think is important to do, to have them spend their money on it, it means we don't have to spend JDRF dollars on it. So sometimes it's a little bit frustrating because the exciting things happen that maybe don't have JDRF direct dollars. That doesn't mean we didn't play a role in getting somebody else to invest those dollars. And what that means is, while we give a tremendous amount of direct funding to research, in FY17 it was $86 million, that money gets leveraged up to about $300 million dedicated to type 1 diabetes research in a single year because we get other people to spend their money. And so we've separated our research portfolio in core program teams that we talk about internally. We work on artificial pancreas. You've heard lots about what JDRF has done in that arena. We still think it's important to keep our foot on the gas pedal there. Obviously, smaller, better, really closed-loop artificial pancreases that don't require boluses for meals, next-generation approaches. Glucose control to make sure the metabolic control is better and better. I will spend a little bit of time diving in, actually a little bit outside of my area of expertise, into our complications portfolio, because I thought it would fit nicely with what Dr. King will say. We spend a tremendous amount of time on beta cell replacement and encapsulation, and you've heard many talks locally about that. We work on beta cell regeneration and immune therapies, and we have a growing portfolio in prevention. And if you have any specific questions on those areas, I'm happy to take them at the end. But what I wanted to just do for a very short amount of time is give you a sense for what we've decided in terms of internal priorities on complications. And that's a very broad area, but we've decided we really wanted to look at where could JDRF make the most benefit in a small portfolio. And we really dedicated our portfolio over probably the last 5 years to preserving kidney function and eyesight through early intervention. And I mean, just to put the problem in perspective, even with breakthrough therapies like the artificial pancreas system, there's still people who develop diabetic kidney and eye disease. We have hopes that that will be decreasing over time, but now, less than 10%, but a real, significant number, 8% have kidney disease, 6% seek treatment for eye disease. And, the good news is that people with type 1 diabetes live longer and longer. It does mean that we will see more complications as people age with type 1 diabetes. And we really think that early intervention is critical. So that means we need to have good ways to diagnose early symptoms, and we need good biomarkers. And that's really where JDRF has decided we can make the most difference. If pharmaceutical companies can't run quick, definitive clinical trials, they won't jump in. So biomarkers is sort of a way to establish biological signs that disease is either progressing or not. So many of you, you all, when you go to your annual physical, your doctor does cholesterol testing. The reason they do that is that's a biomarker for future cardiovascular disease. But we want to have the same kind of biomarkers, easy biomarkers that could be part of clinical trials to predict the progression of kidney and eye disease. And so we've been spending a lot of time first with developing genetics in some populations like what Dr. King is going to tell you about, people who have had diabetes for a very long time. And we really want to use that energy to catalyze the development of new therapies in the area of kidney and eye disease. We do know that there's genetics for type 1 diabetes. There's also genetics for kidney disease, and sometimes they overlap. We know that diabetic kidney disease is about 1/3 heritable in type 1 diabetes. We've funded the largest genetic screen of kidney disease in type 1 diabetes, and that resulted in several candidate genes being identified and validated, which will, we believe, predict new biomarkers and will also predict new drugs that could be made directed to those genes. And so that's been a big success. We've also seen the development of many more trials to accelerate new therapies for kidney disease. For the most part, JDRF has in part funded these trials. They've been mostly funded by the NIH, but we were looking at trials like PEARL to delay kidney failure progression. In Australia, we're looking at a small molecule inhibitor that may halt disease progression. We're looking for robust biomarkers in DKD, and the NIH has funded the Kidney Precision Medicine Project with special diabetes funding. Lots of progress being made. The other area is eye disease, and JDRF has been developing techniques and funding the development of techniques that will allow better scanning of the eye. We've funded a trial to test whether changes detected by this ocular coherence tomography can predict decline in eyesight, and we think that that will lead to techniques that allow for better predicting and monitoring of eye disease progression. We also want to make sure there's a lot of eye disease that is being studied, and many times type 1 diabetes is what we call an exclusion criteria for clinical trials. So investigators say, well, we want a very small and defined population in this trial. We actually want to exclude people with type 1 diabetes. And so JDRF is always at the table saying, no, you have to include people with type 1 diabetes or run a separate type 1 diabetes trial. And we've supported key research in showing that the anti-VEGF approaches can reverse vision loss. We're funding, in part, a phase 3 trial of a new anti-VEGF to prevent vision loss, and we're very interested in ways that are independent of VEGF to control vision loss. And so we've really been at the table where we think there's many big investments being made from other governmental agencies and industry. So we're hoping that that's really going to open up a lot of new techniques in the coming years. And then just finally, before I introduce George, just a reminder that one of the ways that you can get involved is to participate in clinical trials. It's a great way to contribute to research. It's a great way to volunteer for the cause. And JDRF has improved, we think, and let me know if you think we haven't, a method for people to find the right clinical trials. And so if you go to jdrf.org/CTC, you can put in your specific medical history, and it will show you where there are clinical trials across the world that you may fit what we call those inclusion and exclusion criteria. And so hopefully that will help people try to participate in different ways. So the real meat of the presentation today, obviously, is Dr. King, and he's going to tell us about the Joslin 50-Year Medalist Study, lessons learned from medalists and their families. And just to set the stage a little bit, Dr. King is the Director of Research at the Joslin. He is Senior Vice President and Head of Vascular Cell Biology at the Joslin, and he is a Professor of Medicine at Harvard Medical School. He got his MD from Duke. He did his residency at University of Washington in Seattle, and he then went to the NIH, where he was Research Associate and Clinical Associate. Coming to the Joslin and Harvard Medical School in 1981, he's been here since, really driving the energies of the Joslin toward a variety of areas of type 1 diabetes. And I think we're going to show the video clip, and then we're going to welcome Georgia to the stage.
Need some technical.
There's cards at your seats, and so if you can write your questions down.
name is Dr. George King. I'm the Research Director and Chief Scientific Officer at the Joslin Diabetes Center. As you mentioned, I've been studying for 30 years, and it actually doesn't seem to be that long until you keep saying it. It went by fairly fast.
My name is Lynn Wickwire. I've been living with type 1 diabetes for 72 and a half years, working on my 73rd year.
We decided to study a group of patients who have type 1 diabetes for 50 to 86 years. It's called the Medalist Study, originally supported by JDRF.
This medal represents 50 years of living successfully with diabetes. This is incredible for a lot of us just to get past 21 and then to get a 50-year medal. Are you kidding me? And I'm still going strong. The Medalist Study is so important. It allows Dr. King to study this group and make some remarkable discoveries.
We discover these patients were not developing any kidney disease. Their body are making something to protect them. And we think we have found one of those protective factors, and we will be announcing that in the next month or two.
They may be able to reverse some of the kidney complications. I mean, it's just astounding. And this is the research that's going on.
Millions of people develop blindness because of diabetes. We discover a protein that causes this.
The lab developed treatments which resulted in keeping my vision stable.
It's estimated that over 2 million people, their vision has been saved over the last 2 or 3 years. Another discovery we have made from these patients is almost all medalists are still making insulin. That means almost everybody with type 1 diabetes can make insulin. So you could potentially regenerate these beta cells that are making insulin, which would be a wonderful way to cure type 1 diabetes.
You know, I've never thought there'd be a cure. The fact that future generations could be cured, that's mind-boggling.
We absolutely desperately need now for organizations such as JDRF to keep the momentum going.
It really, really, really is an exciting time right now in diabetes research. We couldn't find a better person than George to be doing this.
Be the momentum,
Be the progress.
be the cure. Thank you for coming, and I want to thank Lisa and Dr. Greenstein for inviting me. And it's a nice video, right? Not even we're at the same time. So again, thank you all for supporting the research, the incredible work of you guys. JDRF is so important for all sorts of funding. Obviously, the funds that you raise, as Julia was mentioning, but also the special funding from Congress, a special diabetes fund, and that $150 million a year. I think it's more than 15 years now, right? So that's incredible support, and to help in getting the budget through the Congress. And as I mentioned in the, I don't know if I can say this, but as I mentioned in the diabetes meeting, NIDDK had all the diabetes center meeting 2 weeks ago, that we have the biggest raise in NIH funding since 2004 in the Trump administration. So it's really, really wonderful to have. But my interaction with JDF actually started in 1981. I was invited by Lee Ducat, some of you may have heard of her, and Carol Laura to to New York to present my ideas on how to handle complications. And I've been working on that area for a long time. And actually, I was talking today with you in 1968 when I was in high school. Actually, I worked on one of the first encapsulation technology at that time. So today I'm going to talk to you about, in the next 20 minutes or so, our, I think, incredible, inspiring, certainly to me, work with the Joslin medalists. And what you see here is a picture of the medalist meeting. Every 2 years we have a medalist meeting at Joslin, and we bring them up to date on what we're doing. And that's last year in April. And the lower are the three teams that we have for the medalist study. We have support on both sides of it. The Tom Beatson Foundation, who was a medalist, but he passed away and set up a foundation to fund a lot of the medalist studying and when he was alive and continue to do so. Certainly JDRF, and which started the funding on one of the early start funding for the medalist study. Initially, we wanted to study around 2001. After filing for multiple applications, we were told it's the most ridiculous thing they ever heard. But anyway, finally we got funding. We got funding from JDRF first, then now we have a very nice funding, you never say that, from NIDDK. So let me tell you a little bit what we're doing. So the medalist study was started by Dr. Joslin, who worked to reward patients. Initially it was a 25-year medal in 1948, and then 50-year medal in 1970. We have given over 5,000 medals now, mostly in the United States. And its number is now really rapidly increasing. This is only 2014, and I think this is really due to the improvement in care, because just remember, right now it's 50-year medalists, people who are developing disease 1967, right, 68. But when we started the study in 2004, it was people in the 1950s. So now we have, I said, 25-year medal. We don't give that out anymore because that's just too many. And 50-year medal, we still give that. I proposed last year maybe we should move to 60-year medal, but I got so many negative, hostile responses. I don't do that anymore. So we have 75-year medal, and we just designed 2013. Actually, I helped in designing the 80-year medal. The reason we used to give certificate, and quite a few, we have now 11. All of them are really upset that they get a medal at 75, they only get a piece of paper at 80. So we made it a little bigger. We have to tell them it's not real gold. It's just... so to be part of the study, you're nominated by physician or family to document the 50 years, and then they all come to Joslin to be studied. So we have over 1,000 patients now in our study, and they're incredibly wonderful patients. They are from all over the United States. Every state, including Alaska and Hawaii. And the average age when they start the study is 67 years, and they have about 57 years of diabetes. Many of them have been with us since 2004. So the average age of the group now is over 75, and they are over 65 years of diabetes. The earliest diagnosis was 1925. This is Mr. Anderson, who, even though he passed away, he made me promise that I always mention him. I don't know why I keep going back. Anyway, this is Mr. Anderson. But I think just to give you a little idea of what happened from 1920s. This guy had diabetes since 1925, right? So he had to go through all these years. He was an architect in the Navy. So he traveled all over the world, designing buildings and facilities, and with insulin and so forth. So, certainly in 1922, with the discovery of insulin, that was an incredible event, saved lives. Priscilla White with the Joslin, she greatly improved the success in pregnancy and mother survival, because before, in the 1930s and 40s and 50s even, we get the story all the time with women with type 1 diabetes. Told them, first of all, don't get married, don't have children, and I mean, that's just a very common story from the medalist. Even in the 50s, the doctors were telling our patients those stories. The reason is, you know, it was pretty tough back then. So you have glass syringes, metal needles, and the needle size now is 31 to 33. Those days is 23. So think about 23, your needle size, right? So that's, I don't know, you can stop at 23. When you draw blood, we use 25 and 23s. And Benedict solutions. Then we have urine test strip. I remember test strips. And then these are some of the more recent changes as well. Obviously now we have CGMs, pumps, and this is even older. So I should remake the slide. So things are really improving. This is medalist in 2009. And it's getting bigger and bigger. So last year, as I said, we had over 300 medalists attending. We had to go from Joslin to this big hotel in Cambridge now, just to have everyone and their spouse or significant other who are incredibly important. So, I mean, the first story I want to tell you is what the medalists told us to do. So, when we first started, we were only looking at complications, eyes, kidney, nerves, heart. But many of the medalists said, you know, I think I'm making insulin. So, like any other endocrinologist at that time, I go, yeah, right, okay. But many of them saying, well, can you just measure just so? But we actually put in our grants, and they always cut it out. They go, this is ridiculous. You're wasting thousands of dollars. Why measuring insulin? They have 50 to 80 or 86 years of diabetes. There's no way it could be anything significant. Even as a tiny little bit there, it have no real meaning. Well, it turned out the medalists are right. There was a lady from DC who were insistent, because she told me really incredible stories. She said, you know, every year I only have to take, for about a week or two, only have to take about less than 10 units of insulin a day. Which you may or may not realize, average person need about 30 to 50 units of insulin a day. So if you take 10 units, it's really homeopathic. It's not, it doesn't do very much. So we go, okay, and then I hear that story over and over again. So lo and behold, they do make insulin. Every type 1 diabetic patient is still making insulin. So the reason we can say that is these medalists are incredibly supportive. While alive, they all volunteer. We have 80% of the people we asked to help to participate. I don't know whether you realize how high that is. Most clinical studies, when you recruit is only about 20%. Not only that, over 50% of the medalists are willing to donate their organs after they die. So because of that, with the help of JDRF and others, we set up a network we could actually procure the organ. I know this is morbid, but this is incredibly important. We could get to these medalists within 3 hours anywhere in the United States, including Hawaii and Alaska. And we know where they are. The family is so wonderful. So many of them, they sent me pictures, is that they have 2 phone numbers on their door. So one's for their next of kin, the other is actually my cell number. So they all have my cell phone, over 1,000 of them. So they call me, they're not shy people. The medalists are not shy people, so you should know this. Okay. And when they donate their organ, lo and behold, they do have insulin. What you see is the red color are insulin, cells are producing insulin. Every pancreas we have procured so far have insulin. And not only that, the insulin is not in the islet. So that's a big discovery, is that the insulin is actually outside the islet. And they survive. So the question is, why are the islets outside the insulin? If you can see, singlets. See the singlets outside the islet? See that? And so why do they survive? And why does the beta cell inside the islet actually get killed off, right? And the even more remarkable is that they're still growing. The Ki-67 panel, you see that, shows that the beta cell is still growing, proliferating. So they also are dying. Tunnel, T-U-N-E-L, tunnel is a measurement of the cells are dying. So this is a patient with 86 years old and with more than 76 years of diabetes. And I kind of want to tell you a story. He says he's from Guatemala. We thought we had our first Hispanic medalist. Then I saw his name. I go, this is a New England name. So I called him up. I said, you say from Guatemala? He goes, yeah. He said, I lived there, forever. I said, what kind of your name? He says, yeah, originally I was born in Bedford. I said, yeah, you sound like from New England. So anyway, so this is really exciting because that means you can regenerate. Your body can actually regenerate. Not only that, I don't have time to tell you, we can actually for the first time show that some of the patients, even though they initially don't make any insulin in the blood, you follow them for 3 to 10 years, bring them back 3-4 times, they actually can make insulin. So that's actually not known before this study. And recently, we did something called arginine clamp, because people say, okay, so they have beta cell, does that mean they respond to glucose, to stimulant, right? Because otherwise it's just sitting there, not doing anything. So this is some of the patients we brought back and did an arginine clamp. Lo and behold, they actually respond. So we know that, see the little peaks, and so they do respond. So that's really, really exciting. So we know that they have surviving beta cells. They're usually not in islets, and they are functioning. They have waxing and waning patterns. And so that means suggests we can actually regenerate these cells. And so certainly transplant is important, but we bet a significant number of the type 1 patients actually can regenerate their own beta cells. So that means, so I'm very happy to hear that you are putting a lot of support on the regeneration aspect of the beta cell. And how can you regenerate them? Well, one thing is what could be causing the autoimmune process. So I'm sure y'all heard about the gut bacteria. So I was glad that nobody's eating here, so we're going to talk about fecal materials now. So we have a lot of bacteria in our gut, a lot more genes there than in the our own genes. And there's been a huge amount of interest in this, so we have recruited one of the superstars in this area, and he's very young, to really study this, and he is supported by JDRF to see whether the gut bacteria is related to the medalist's ability to keep their beta cells to survive and proliferate. And the fecal bacteria has been shown to certainly type 2 diabetes, obesity, celiac disease. That's actually moving on very rapidly, how you could potentially prevent celiac and disease. As you know, celiac disease genetic-wise and diabetes type 1 is very close. Actually, 17% of our medalists have another autoimmune disease, and a lot of them have celiac disease as well. So, what has he done? Oh, okay. Well, he has shown that it's possible the gut bacteria is the reason for some of the type 1 patients develop the autoimmune process initially by itself, by looking at a pattern of the bacteria. If you look at the green is the gut in the patients, in people who don't have type 1 diabetes, but if you follow their siblings or cohort who develop type 1 diabetes, you can see that the variety of bacteria drops off. You see that? And the reason this is occurred to people is in Russia and Finland. People know where Russia and Finland are, they're right next door to each other. Okay. And it's separated, in this area, it's separated by a mountain. So Finland has highest rate of diabetes in the world. Okay? But genetically, if you cross this mountain, it's the same, the people. They have at least 5 to 10 times less type 1 diabetes than the other in Finland. So in Estonia and Russia, they have 5 to 10 times less of that region than type 1 than Finland. Genetically, essentially the same. So clearly something in the environment, right? So so Dr. Kostic essentially traced it to potentially certain species of bacteria in the gut. This is so-called the clean theory, right? I'm sure you've heard of that. Because this is not just type 1 diabetes. Look, asthma. Asthma in China, Canton, is 5 times less than Chinatown in New York. Genetically, it's the same. Why is it Chinatown, New York 5 times higher than Canton, which is thought to be polluted air and everything, right? So this is a very exciting work that Alex is doing. And again, we're looking at the gut microbiome of the medalists and see how they differ between those who have diabetes, who have islet cell and C-peptide. So the hope is obviously to regenerate the diseased islets to a normal islet with lots of insulin. So complications. This is eye disease, and we're searching for protective factors. This is a patient who's now close to 80. His eyes are absolutely normal. There's nothing wrong with his eyes. We take pictures every 3-4 years. This is some of the patients who have passed, but if you look at one to your right, 84 years of diabetes. When he passed, his kidney, he gave us the whole kidney. And it's totally normal. This is, the other side is a diseased kidney. And what we did was we just asked a simple question. If we take the diseased kidney, certain parts, and because we could now take a lot of these material, because they gave us the whole kidney, we take the people who are protected, even though A1C was 8.8, we could modulate for the last 20 years or so, very high A1C. And those people who are not protected, protected means they already have the kidney disease. With A1C was 6.5. We took their kidney and just said, what are the difference? Genetic, proteins. And the good news is, as I said in the movie, that we're going to announce it, so I'm going to announce it now. We published it last summer. So looking for these protective factors, we're very, very excited. We went through the proteins in the good and bad kidneys. We found 88 protein initially. Through a variety of process, we identified a bunch of them. Lo and behold, it surprised a lot of people. I don't know why it surprised people. Most of these genes is how the cell handle glucose. Okay. But the surprise is everybody thought there's too much glucose coming in and made the pathway burn, work too hard. And but turned out the body in these people who are protected really rev up the cells on how to take care of the glucose. As glucose come in, they essentially just use them all up, process them, got rid of them. And so all these enzymes you see in red are up. So these kidneys are working extremely hard, but great. They just ripped up. So people thought that was terrible. So in the opposite is what we found when we actually looked at the patient. And one thing is the aldose reductase, sorbitol, up there. So I think Julia knows that since it was thought that you want to inhibit this pathway, 1968 when we first thought you want to do that, Pfizer put $8 billion looking at inhibitors. It's hard to see it work. Now we know why it doesn't work. Because the body actually ripped it up to use up the too much free glucose inside the cell. So you rip up everything. So we have done is with the arrows pointing, we decided to interfere at that point to activate. If you don't have all these enzymes and genes to activate, how are we going to extrapolate this to everybody else, right? So we're going to activate something called PKM2. And how are we going to do that? We developed a small molecule with actually Sanofi, as mentioned, that you really need a pharma to help you design drugs and carry forward. And we have a small drug called TAP46. It's probably not going to use clinically because of different reasons. And but the good news is, in animal, that we could show we could actually reverse. This is the first time. Most people do animal studies, they can prevent the kidney disease, prevent the eye disease. But when they translate it into human clinical trial, it's always intervention. So that hardly ever works. So we said, okay, we're going to make the rat or mice diabetic for 4 months. They already have the disease. And even if you transplant with insulin at that time, the kidney disease and eye disease will continue anyway, even though the glucose is totally normal. So at that point, we treated with this agent, activate PKM2, and it totally normalized the kidney in the diabetic rats. So we're very happy. That's actually now in more drug development than anything. And also we're trying to understand at the basic science level, why is it working, right? So I'm not going to talk about too much about eye today. We also have isolated protective factor for the eye as well. We've been working on the eye in my first project in 1981, which is one of the first things that was funded by JDRF, was actually to look at the treatment for eye disease. So many of you, some of you may remember, when I first went to Joslin, 1981, every day we'll see 2 or 3 seeing eye dogs in the clinic. So now, at that time, 40% of diabetic patients will actually become legally blind. 40%. Just think about that, right? But with all the advancement, laser, our discovery of VEGF, you heard about anti-VEGF treatments, now at the best institution with frequent follow-up is less than 1%. So we know you can find cures. So I mean, look at 40%, at Joslin now with our patient is less than 1%. Nationally, it's about 3%. Legally blind. Legal blind is 2,200. That's still not good. Okay. 2,200, you can't drive. 2040, you could barely drive. And laser is a treatment, but it's still not good. I don't know, anybody have laser? Right, so I had a patient, she was 23 when I was walking with her in San Antonio. There's a river in San Antonio in the middle. I don't know what to call it, I call it a little muddy river. Back then, before they built it up, there was no banister. And I was walking with her at an ADA meeting, and she kept walking into the river, falling. I had to keep grabbing her. I said, why you keep, she said, I can't see, I just got laser. So when you have laser, you can't see differences, right? It was also during dusk, where the light is contracts low. So because of laser, she can't actually see where the river starts, where the walk starts, right? So she keeps walking to the river. So it's not perfect, but we now, the anti-VEGF treatment is wonderful, but we think we actually have a new protein that you could hopefully reverse the diabetic eye disease. And we gave it to mice and rat, totally reversed that, and so we are very excited. And like I said last year, we'll announce this one this summer. Okay, so that's going to be exciting, and we'll be working with another pharmaceutical company as well. A couple other things. Exercise. Exercise is incredibly important. So we tend to focus exercise on type 2s. But look at this. If you are male, if you exercise, you have 4 times better chance of diabetes, heart disease, and survival. So if you're male with type 1 diabetes, I will go out and exercise. Now, female doesn't seem to need it because something they have in our medalist is something called HDL. See the second line called HDL? The female women with 50-year medalist has, so exercise, what kind of exercise? Anything. One of the major exercise for our type 1 patient is actually ballroom dancing. I don't know if anybody does ballroom dancing here. When they first told me, I poo-pooed it. Okay. I go, how could that be exercise, right? So they invited me to one of their practice, not even a real session, a practice session. It's a lot of work. No, seriously, you get all sweaty. And after an hour, it's a huge, huge amount of work. And easily 10,000 steps. If you have a Fitbit, it's easily 10,000 steps in 1 hour. So this is Tom Beatson. He's ridden 100,000 miles on his bike. But HDL is something the women, for some reason, with medalists have very, very high HDL. The average is actually over 70. Normal in the US without diabetes is about 50. But women with medalists is over 70. You heard of the centenarian study. Almost every centenarian, actually every centenarian has HDL over 70. So this is really something you want to pay attention to. So let me just finish here that A1C, our medalists are very good. They're not overweight, but most type 1 are not overweight. They have very few smokers. We have, I think, 4 smokers. Exercise frequently. HDL is very high. We have identified proteins now for eyes and kidney, which I think will be helpful. They also have a very, very positive outlook. And we actually did a psychological profiling on them for that. They also have very good genes. All the parents lived until 76. Almost all of their parents now, which means they're born before 1900. And so that's very, very exciting. Just to leave you with a couple of vignettes. This is Mr. Myers. And they all have this attitude, They can do things. It may come back last, but that's okay. And, but they can do it. We have people who run marathons at 70s. You know, as I said, I get called every 2 or 3 days from one of them to tell me what they're doing. They're wonderful people. So let me finish here. Their medalists are great. Their survivals depend on their support groups, and they want us to give the medal to their spouse, or because who's going to help them 2 o'clock in the morning? Initially their parents, but 30, 40 years later, it's somebody else, right? And the doctors can't be there, so they're incredibly helpful. And thank you for having me.
Thank you, George. That's amazing. Do we have any questions? Or somebody's going to collect cards. I don't know if we have any yet. George, one of the things we've been pondering, I totally remember, I'm an immunologist by training. When I learned first about type 1 diabetes, it's like the mantras, people, the beta cells are destroyed by the immune system. There are no beta cells left, and that is so not true nowadays. What do you think, when you think about the immune system and those beta cells that are surviving, what do you think is going on there?
Yeah, so I think, I'm terrible at immunology. When I was in medical school at Duke, there was a very, very famous immunologist there, and he came to me in the class and goes, "Mr. King, if I let you pass, would you promise me never do any research in immunology?" So I'm always avoiding. But I think with all the exciting things, and some of you supported by you guys, Dr. Stefan Kessler, Pang Yi, are looking at this, the beta cells, some of the beta cells have genes that actually protect themselves from the destruction, because what they found was interesting is whenever they transplant, let's say that you transplant 1 million beta cell into a host, like a NOD, autoimmune type 1 mouse, it's always a few hundred beta cells survives. So okay, 900,000 dies, but why does those 100, 200 survive? It's the weirdest things. So now they have a way to look at it. So they actually have identified potential genes that's protecting the beta cell from being killed. So then the whole idea is, can you put those genes and amplify them in all the beta cells? Then you don't need all the beta cells. So let's say you have transplant. Let's say we could transplant beta cells, right? Instead of having to, they get destroyed very quickly. But what if you only have to, if you get this other treatment, and you could transplant, now only have to replace it, this in a cassette or something, every 5 years. Now, is that a cure? Is that not a cure? Remember we had this huge, another JDRF had a thing, a discussion a few years ago on what is a cure. We spent a whole day discussing what is a cure. I don't know we need a whole day, but it was quite interesting. So that's one possibility. And then is another group is now trying to, looks like different type of subset of T cells are regulated potentially by the gut bacteria. That's a totally new data just found just a week or two. So again, the T cells in the gut are being reprogrammed. Tregs are being reprogrammed in the gut by the exposure to bacteria, so they can actually control naturally. I don't know.
Thank you. So actually, the first question is right along that line. Is I think you've convinced everybody that medalists, so greater than 50 years, and part of the Joslin study, all have surviving beta cells. What about other people with type 1 who haven't reached the 50-year point?
Oh,
Do you
no,
think it's 100%, or
yeah,
do you
I
think
think
it's almost
100%. I'm totally convinced every type 1 diabetic patient have beta cells. Certainly, first 10 years, they're still making it. DCCT, since our study now, are still looking at the C-peptide production, and they have the same overall C-peptide percent as we do. So there are, we are looking at another second part of our study is people from 30 to 49 years, and we don't see any difference from 39, from beta cell point of view, from 30 to 49 years. So we're moving downwards.
So somebody wants to know if you're still recruiting volunteers for your 50-year study?
Well, that's a little more difficult. We actually closed our study because we already have 1,000 patients. The reason for that is funding, because essentially we're funded to 1,000 patients. And, but we are still taking, we give everybody a medal. So everybody's getting a medal for 50 years. We are selectively recruiting a few patients, certainly if you have 60 years, because remember we're looking at protective factors. And we just published a paper showing that the demographic of people who are just turning 50 years and those who previously were recruited at 60 years, who are 60 years now, are actually quite different. So people who are just turning 50, some of the complications are now actually do correlate with glucose control, whereas people who are 60 years or longer do very little correlation.
So one of the other questions is, who do you contact to donate your body parts? And as
Just
Dr.
contact
King
me.
says, yeah, call him, his cell phone.
I mean,
On the
my
bottom.
email's everywhere.
But we also, so another thing that JDRF did now 10 years ago is form the Network for Pancreatic Organ Donation. And that was begun at the University of Florida by Mike Atkinson, again saying, we really can't understand type 1 diabetes without knowing what's going on in the pancreas. And the pancreas is not a good organ to biopsy. It's kind of a yucky organ if you had to describe it. It's not in a good place. And Mark Atkinson and actually the late George Eisenbarth said, if we could get people who die from any cause, but have type 1 diabetes, to donate their pancreases, we could start learning a whole lot about the beta cell biology, about the immunology, and about a whole lot of stuff. And most people thought they were crazy. We ran a big panel, the NIH came in, everybody came in, and everybody said, you won't be able to do this. It won't be worthwhile, and it'll cost a lot of money. And after much thought, JDRF decided, this might not work, but if it does work, it will change our ability to ask questions about human type 1 diabetes and not just mouse type 1 diabetes. And so we did a little demonstration project with Mark and his team, and that evolved into the next 10 years of funding, where there are now tissues available for researchers around the world from people with a variety of times of diagnosis for type 1 diabetes. We have type 2 diabetes, some controls. And we've started to learn a tremendous amount about what the pancreas looks like in people with type 1 diabetes, people who have autoantibodies and don't yet have a diagnosis of type 1. And it's really changed the landscape about what we understand about the biology, and has opened up a lot of avenues. So you can donate organs to NPOD. Again, they are selective depending on what they need. It's not an open bank because we honestly can't afford that kind of effort. But if you go on to the JDRF NPOD website, you can see how to donate and what's going on in NPOD. Do medalists have a lower autoimmune response?
I mean, I don't know how. It's very difficult to quantitate autoimmune responses because, how are you going to measure it? is it 10, is it 1? I mean, how do you measure that, right? So the titer of the autoantibody doesn't really tell you what they are. I actually don't think so, because many of them are, when they first came, almost every one of them, they're brittle. They are hypo, they have a lot of hypos. When we first, part of our study is mixed meal tolerance test. So that means they have to fast overnight. And when we first proposed that, RRB was totally worried, because you're going to fast 1,000 type 1 overnight. That's unheard of, right? They're going to, you know, something bad is going to happen to them. So we have done 1,023 of them one time, 187 of them twice at least, and we haven't had a single problem. But because they watch themselves so carefully. So these are different people. I'm not going to tell you they're not different. They are slightly obsessive, right? Most of them come in with their suitcases of their medical record from day one. And, no, really. So they pay attention. We have 70%, they are 80-year-olds, 70% on insulin pump, 50% on CGM. When they are, even when not paid by Medicare, they bought it themselves. So now it's wonderful, they'll pay for it, but so they buy it themselves. So they are really open to any innovation. That's why they love to participate in research. They want to contribute. And no, it's really wonderful.
So maybe as getting near to a final question, I didn't write this, it's not my handwriting. Is there a working cooperative relationship between JDRF and the Joslin?
Oh, yeah. Oh, absolutely. As I said, I've been supported by JDRF since 1981. Every year we have, maybe I shouldn't say that, we have
You better knock some wood.
over $1 million of support from JDRF, from all the grants. So, and I've been a research director since 2000. So that's 17, 18 years. And so, I think we collaborated and worked very well. I mean,
I'm glad George thinks that, because we certainly think that.
Oh, is there any? I didn't
No?
know.
If there was, you'd know about it. You know, I think that, you know, we certainly fund all over the world, and we look to fund the best research, but, you know, there are institutions and states that are always big recipients of JDRF funding, and Massachusetts and the Joslin are always among our biggest efforts.
We have 7,000 type 1 patients. Everybody know that in our clinic? We have 7,000 active type 1 patients. That's the biggest in the world. I don't know whether you realize it.
I mean, the other thing is, you know, we use expert scientists to review all of our grants that we consider. We use many of the Joslin scientists to do that. We use many of our Joslin colleagues to help us and our scientists sort of when we survey the landscape. There probably isn't a scientist in the type 1 diabetes world that we honestly can't pick up the phone and call and get them to spend time explaining their work or their opinions about other people's work and where they think JDRF dollars should be spent. A lot of times they think that JDRF dollars should be spent in their labs, but after we finish that conversation, they're very helpful at sort of helping us survey the landscape. And so we work very closely with the type 1 community of
And
scientists.
just one more thing I forgot. Actually, we're going to have our first summit on the Medalist Study this summer. Amongst the 8, now there are 8 groups because of us. Now there are 8 groups around the country, around the world, who are studying, have a Medalist Study, and JDRF is going to partially support with Tom Beeson's foundation. So we're going to bring all 8 groups in Orlando, spend a day, try to coordinate because we want to really coordinate everybody's activity, right?
Well, thank you, George, for that.
Thank you so much, Dr. King, Dr. Greenstein. That was enlightening and inspiring. I think having a positive attitude is obviously a key thing right along with exercise and having good hormones and good macrobiota. But I just want to thank the both of you for being with us today, and most importantly for what you're doing each and every day to better the lives of all of us whose lives have been impacted by type 1 diabetes, and we feel very, very grateful for your ongoing efforts. I also want to thank, for those of you who don't know, we have a couple of Bentley students here that have volunteered their time to come and record this presentation. So if you want to watch it again or share it with others who couldn't be here, thank you so much for doing that. We really appreciate your efforts and I of course want to thank the outstanding JDRF staff, our new executive director Liz Mullane, who's been with us just since January, Christina Roach, who put this incredible program together, and all of the JDRF staff that are here giving hours and hours and hours each and every day into the late night to partner with us in this effort to rid the world of type 1 diabetes and its complications. I just want to share, it's up on the screen, a few opportunities to engage with us in the future. We have our gala coming up on May 12th. There are many people in the room that have been working very hard to make this night a huge success. Elizabeth Wetzelblatt is somewhere here who's chairing the event. Thank you for your incredible efforts, and so many members of the gala committee that are here. That is a spectacular evening of coming together to celebrate our progress and how far we've come, but also to really renew our commitment to doing better and bringing about the cure and ongoing important developments. If you're interested in learning more about the gala, either to come as an attendee or as a volunteer, please let us know. It says that we have the annual meeting here in this very same room on June 19th, but we're actually going to call it something better than that. We're in the process of figuring out how to make this sound a little bit more exciting, because there's so many things going on. We want to summarize everything that's happened this year in the chapter and in JDRF as a whole. And if anybody has a better idea, an annual meeting as to what we can call it that will make all of you and others come back to this very room and hear this important recap, please do let us know. We have another event, the annual Tee Up to the Cure Diabetes Golf Classic, happening on July 16th at the don't do this to me, sorry. Quindinesset Country Club, where I've been many times. It's lovely. And of course, before we know it, we'll be back in walk season with our JDRF 1 walks coming up again right around the corner. They come really quickly right after the summer, so start thinking now about participating in one of our walk locations. It's a great way to come out and show our support and to get our friends, colleagues, neighbors, anybody that we come across to join us in our shared quest to fund the research that's needed to cure type 1 diabetes. So thank you, everybody. I think there's dessert next door, and hopefully we'll see all of you again back here on June 19th for this soon-to-be renamed annual meeting, and hopefully some of you at the gala as well. And thank you very much for your ongoing support. Appreciate it.